Like, share, and subscribe.
So we are looking for the number of molecules in the bloodstream 3 hours after the drug was taken. So this is an equation that describes the molecules, the number of molecules, and T is time, which is measured in hours in this case. So to answer this question, they want to know the number of molecules after 3 hours. See how that is? You just substitute 3 where you see T. So it becomes minus 3 cubed, 3 to 3 squared, plus 72 to 3. And that will be minus 27 plus 27, because 3 squared is 9, 9 times 3 is 27, plus 1 over 72 times 3b, and that's 216. So of course these two will cancel out, meaning the solution is 216. So in other words, there will be 216 molecules after 3 hours in the bloodstream, that is to say. So whenever they talk about rates, I need you to think of, now this is to the people that don't really do calculus as their main subject, neither do they do chemistry or physical sciences. All right, so in most cases when we talk about rate, we simply refer to the gradient. All right, this is it's a measure per time, basically a measure per time. See, this is what a rate is. So in this case, they want to know the gradient, or the rate at which, like they say, number of molecules of the drug, changes in the bloodstream. So of course we know the rate, as I said, to be the gradient. So the way you express a gradient in equation language is you derive. So the rate in this case will be the first principle, or rather the first derivative. So that will be the first derivative of m of t, and that becomes minus 3t squared plus 6t plus 72. See, so they want to know the rate at exactly 2 hours. So maintaining the fact that t is actually time and it's measured in hours, so that is minus 3 into 2 squared plus 6 into 2 plus 72. You just do the mathematics from here. That'll be minus 12 plus 12 plus 72. So once again, that will be solution is 72. So that means the rate at which the molecules in the bloodstream change at exactly 2 hours after the drug is taken will be 72. So once again, we have the equation that describes the number of molecules in the bloodstream to be T2 squared plus 72T. So this is the equation that describes the number of molecules, right? This is the number, sorry. So this equation describes the number of molecules So now I mentioned that the first derivative of this equation will describe the rate. All right, so this is minus 3t squared plus, if you derive this, of course, 6t plus 72. Now they want to know the question says how many hours after taking the drug will the rate, see, so in other words, we're going to derive the rate. So the question is with the rate. They want to know how many hours after the drug will take, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream changing to be a maximum. So again, this is just them asking us to find the second derivative, basically. So meaning you're going to derive this further. So it's going to be minus 6. So this is the equation that describes the number of molecules. This would be the one that describes the rate in which these molecules are changing. And this is the rate of the rate. So this is like the rate at which the rate changes. See? And this will be the equation we're going to be using to answer this question, because it asks that how many hours after taking the drug will the rate, see, so we are studying the rate, or investigating the rate rather, at which the number of molecules of the drug in the bloodstream is changing, be a maximum. So again, anywhere where we talk about maximization, in this case we will equate the second derivative, the rate of the rate, to 0. We already have the function there, so that will be minus 6t plus 6, sorry, equated to 0, and of course minus 6t, and you subtract 6 on both ends. That of course means that t is 1. So in other words, this rate at which the number of molecules in the drug in the bloodstream is changing will be a maximum every hour. So basically it's, or rather let me say, it's after 1 hour according to our calculations.